this video we are going to learn the ultrasonics or ultrasound and some other parts. Ultrasonics and sound waves of high frequency at or above the upper limit of hearing, which are inaudible to the human ear, and since velocity is equal to wavelength into frequency, ultrasonics have short wavelengths compared with sound waves in the audio frequency range. Generation of ultrasonic vibration. There are several generators of ultrasonic vibrations and are grouped to the mode of excitation. They are mechanical generator, thermal generator, piezoelectric generator, magnetostrictive generator. Source of ultrasonics. Ultrasound is deliberately produced either as continuous or pulsed beam, which has a variety of uses in industry such as drilling, welding, plastics, mixing liquids, washing machines, etc. So, effect of ultrasonics. Physical changes due to absorption of ultrasonics, that is acoustic beams. When the acoustic energies like ultrasonics are propagated within a medium of living material, there are three major events observed which may be considered as physiological effects of the beam, like temperature effect. Two types of temperature changes occur in the absence of cavitation. A periodic temperature change associated with condensation and rarefaction. A steady temperature is associated with the absorption of acoustic energy. The temperature changes are very small and less significant for production of biological effects, but pressure variations will be occurring, like experimental studies reveal that a beam of 35 volt per EM square produces pressure changes up to 10 atmosphere, but it is doubtful whether this pressure is sufficient to produce any change in the properties of protoplasm. Other factors which are influencing the response of living tissue are radiation pressure and viscous flow of medium particles. The forces produced spatial disorientation in parts of the drive-in system. Such disorientation may result in alteration of biological function. Cavitation will be happening. Cavitation means physical separation of liquid layers, which occurs on drastic reduction of hydrostatic pressure, providing gas molecules. Physical separation of liquid layers is happening, and there will be reduction of hydrostatic pressure, and there will be gas molecules. Expansion of gas nuclei occurs under negative pressure, allowing other molecules in the space to form bubbles. Cavitation is necessary for occurring the effects of ultrasonics. The liquefaction of theotropic gels and then the reduction of viscosity of the structure of some materials, disruptive effects on single cells, etc. Next, biological effects are also there. The biological effects of ultrasonics are the same as those of sonics, but the difference that production of large intensities are much easier in the ultrasonic range than the sonic range. The biological effects are the heating effects will be there. Like these are the primary effects with low intensity beams. Heating effect of high intensity ultrasonics is partly due to absorption of energy and partly due to cavitation mechanism. The cavitation causes very high local temperature. Lipid and protein materials exhibit increase of temperature in ultrasonic beams associated with acoustic absorption. Other less viscous materials may show large cavitation temperature changes. Next is the paralytic effect. The paralytic effect of ultrasonics with moderate intensity beams are similar to be produced by extensive intense audible range. When exposed chronically to this ultrasonic sound, ability show decreased ability to concentrate and may suffer loss of equilibrium. Then some scientists exposed frogs to beams of about 35 intensity. F is equal to 1 megacycle per second and observed that 4.3 seconds of exposure produced paralysis of the hind legs. Isolated peripheral nerve were not affected by the beam with prolonged exposure. The above experiments indicate that temperature increase is slightly responsible for paralytic effect. Again, hydrostatic pressure of 13 atmospheric pressure decreases the paralytic effect, by ultrasonics, which does not clarify the physical basis of paralytic effect. Next, lethal effect will be there. Lethal effects are produced at high intensity beams. These effects are associated with cavitation for the most part. Protozoa experience lethal action on protozoa by ultrasonics has been manifested by paralysis of death depending on the exposure. Large protozoa were much susceptible than small ones because the small one did not undergo large internal pressure change. Next, Abacia eggs are destroyed, tobacco mosaic virus are inactivated, RBCs and other some bacteria are destroyed by high intensity ultrasonic beams. Yeast cells lost their reproductive powers upon the presence of ultrasonic sound. Luminous bacteria lose their luminosity. The evidence indicates that the lethal action of ultrasonics are a direct or indirect result of cavitation. The destruction of protozoa can be reduced significantly by application of high hydrostatic pressure. The reaction of lethal action is due to rapid motion of cell material subsequent to cavitation and formation of minute bubbles. Sterilizing effect will be there. It is not so much effective. It disintegrates only a few bacteria and only some of these are fully destroyed. The factors influencing the efficiency of ultrasonics are sustained sterilizer are viscosity of suspension, shape of the container, large arguments are larger. Animals like frogs, fishes, etc. may be disabled or killed by acting on some vital cell or group of cells. Minor effects of ultrasonics will be there, like electrical charge are produced at the air-gas interface when cavitation occurs in the presence of dissolved gases. These electric charges cause formation of H2O2 in the presence of dissolved air and may cause secondary chemical effects. Dispersion and emulsification of mixtures in liquid suspension, coagulation or agglutination of materials in gas suspension, acute and chronic effect will be there. Pain in the parts of the body, exposure to the direct beam. The ears, dizziness will be there, and noises will be produced. Nausea, headache, fatigue, and irritability. Chronic effect, there is no adverse effect regarding this. Avoidance of exposing the body to the direct beam, as in radiography or lasers. Guarding the operator from the source of wave emission by screening. It might be necessary in some applications to provide ear protection. Glass down wool. Biological importance will be there, like echo depth sounding. Ultrasonic waves, because of their extreme short wavelengths, can be obtained in narrow beam and hence can be conventionally used in echo depth sounding. The time taken by the wave to reach the bottom of the sea from the surface and back being determined are used in coastal vessels and submarines. This directive property is used for the flight of birds in darkness. Night fly of bat. The bats emit sequences of ultrasonic waves from the larynx and hear echoes as a result of reflection. These echoes are reflected back and sent back to the ear, and bat can fly skillfully in the night. Some insect-eating bats that feed on the wings of insects have a keen sense of hearing which guides them in the dark. It is believed that the highly sensitive nose of the bat acts as a recorder and picks up air vibrations set in motion by the movements of other animals and also the vibrations reflected from the stationary objects through a continuous vocal utterance made by the bat themselves. These supersonic utterances are pitched on a key too high for the human ear to hear. The vocal sounds made by the bats have frequencies ranging from 50 to 50,000 kilocycles per second. The bats have also a relatively deeper voice which we hear as high shrill sounds. It appears that the nose and the ears of the bats are both important factors in the radar operation of bats. Next, dolphins. Dolphins are aquatic animals who makes all sorts of sounds like chirps and squawks with which they communicate with each other. Dolphins also emit high frequency sounds and are able to detect objects by the echoes received by them. Thus, they are able to avoid fishing nets and detect fishes at night or even in murky water through which it is not possible to see. This process is called echolocation. Fish trawlers. The trawlerman is able to locate shoals of fish and their distance from him by a simplest echo sounding arrangement. The transducer keeps the turning and sending ultrasonic pulses along different directions. When the pulse falls on a shoal of fish, it reflected and the direction and distance of this shoal from the trawler can be determined. Dogs can hear up to a frequency of 40,000 hertz. This dogs can be trained for special purpose to an ultrasonic whistle which cannot be heard by human beings. Dispersion. Ultrasonic wave causes mixing of immiscible liquids such as water and oil to form a homogeneous solution. This is known as dispersion and emulsification or homogenization. Homogenizing milk. Milk is agitated with ultrasonic vibrations so that the larger fat particles break to form smaller particles. Ultrasonic vibration used for homogenizing cosmetics. Dissipating fogs on runway. Coagulation or agglutination will be happening. Like coagulation or agglutination may be done under the influence of ultrasonic vibrations to form heavier particles. Disruption of organic molecules will be happening. High polymers and molecule chains may be disrupted by such high frequency vibrations. Killing of small animals can be done, like ultrasonic vibrations can kill fish in water, protozoa and red blood corpuscles. Sterilizing effect is observed. Ultrasonics is not so much effective because it can disintegrate only certain bacteria. Only some of the bacteria show full effect, and depending upon the shape of the container, viscosity of the suspension, etc. Disintegration and fraction of organelles will be there. Breaking the tough cell wall. In bacteria, yeasts, and many plant cells, much more rigorous procedures are necessary to break the tough cell walls by sonic radiation, grinding with sand, or fragmentation in a high pressure press. Clinical field. It's used in the diagnostic field, like in the ultrasonography field. The instrument is used to localize the pathological condition in the organs like liver, gallbladder, pancreas, kidney, urinary bladder, uterus, etc. The principle is similar to the sonar device used by bats and submarines. Like echocardiography, it is used for anatomical imaging of the heart. Doppler ultrasonography, it is used to assess abnormalities of blood flow. Color flow Doppler will be there. Color flow Doppler is a method which calculates mean blood velocity and the direction of flow at multiple points down each line of image sector. It gives a dynamic representation of information on the velocity of blood throughout the cardiac cycle. For location of brain tumors, for obtaining brain ventricles, etc. Next, for location of foreign bodies and non-radiopaque calcified masses such as gallstones. Measurement of thickness of intestinal mucosa in obstetrics and gynecology. It is used for detection of pelvic mass, tumors, pregnancy, ovulation, site of placenta, and texture, etc. During labor, it helps to assess the fetal conditions, fetal distress, or a detection of the cord loop around the neck. Postpartum placental lobe retention. It can detect fetal abnormalities. Therapeutic importance and diseases where localized heating is indicated as therapy. In these cases, ultrasonics of low intensity is given. Beam of concentrated ultrasonic waves can be directed to delicate organs inside the body, and the pathological tissue may be destroyed, and the process is known as knifeless surgery. Due to variation in density of tissues and types of tissue interfaces, tissues selectively respond to ultrasonic treatment. Tissue destruction with high intensities like bone, intestine, etc. Treatment of pain syndrome, and ultrasonics are being used for resolution of painful scars. Next, what is the advantages? Non-invasive procedure, quick procedure, no radiation hazards, helps to narrow down the provisional diagnosis, and when used with the clinical data, it may help to come to an exact diagnosis. It is not only visualize the organ but also indicate the shape, size, and texture. It detects physiological and pathological collections of fluids, both generalized and localized. It also informs whether a mass is cystic, solid, or mixed. Next, learn about echocardiography. After introduction of ultrasonography, it was much easier to diagnose the pathological condition of the organ. As for example, in case of diagnostic cardiology, it has supplemented cardiac catheterization for most indication. Ultrasonography is employed for M-mode echocardiography for anatomical imaging of the heart, Doppler ultrasonography for assessment of abnormalities of blood flow, color flow, Doppler ultrasonography for dynamic representation of information on the velocity of blood throughout the cardiac cycle. The basic principle is that ultrasonic waves are of extremely short wavelength and can be obtained in a very narrow beam, and hence can be used to echo depth sounding. This principle is being used by the submarines and coastal vessels for ocean depth. The principle is also used by the bats during their flight in darkness. The bats send out ultrasonic waves and hear echoes as a result of reflection from the obstacle in front and changes their direction. Imaging echocardiography. The principle of echocardiography for anatomical imaging of the heart is based on echo depth sounding device employed by submarines and bats. Ultrasound is composed of mechanically inducing sound pressure wave, which is high frequency sound, and for above the upper limit of hearing of man in the range of 50 to 20,000 hertz, and having frequencies of 1.9 to 7.5 megahertz, which are used in the echocardiography for heart cardiac imaging. In this range, there are better penetration and higher resolution. Generation of pulse of ultrasound is done by passing an electrical current to vibrate the piezoelectric crystal. This generated ultrasound travels at 1.540 meter per second through the body, and most of the sound energy is either scattered or absorbed during transition, but a little amount is reflected at the interfaces between the tissues having different acoustic impedance like pericardium and myocardium. The reflected pulses are detected by the receiving crystal. Density of the spot on the screen is controlled by the magnitude of the received signal. The time difference between transmission through the body and the reflection of the pulse determines the position of the spot. Formation of two ultrasonal sector scan pulses are transmitted along 120 lines over a 90-degree arc 13 times per second. An M-mode image is formed due to transmission and recording at only one scan line out of 120 scan lines. The returning echoes are displayed as a graph of depth against time.